Now, let's see the question number 3. Why is the following situation impossible? The object of mass m equal to 4.00 kg is attached to a vertical rod by two strings of length L equal to 2 meters. The strings are attached to the rod at the point a distance d equal to 3.00 meters apart. The object rotates in a horizontal circle at a constant speed of v equal to 3.00 meters per second, and the strings remain taut. The rod rotates along with the object so that the string do not wrap onto the rod. The system is something like this. You have a rod and you have string attached to an object, and the top and bottom of the rod is 3 meters. Okay, and the length of the string is 2 meters. Something like this. The mass of the object is 4.00 kilogram. Okay, and it's rotated with the velocity equal to 3.00 meters per second. Okay, and the system rotates like this. And let's say that the string, both strings remain taut. So it means that you must have some tension on the string. So I denote this as a T1 and this as a T2. Okay, in this problem, the unknown is T1, the unknown are T1 and T2. So we want to calculate this T1 and T2. If I denote this angle as theta, so from the symmetry, this is theta also, right? So you have T1 minus T2 T2 cos theta must equal to the mg, and you have T1 plus T2 sin theta must equal to the mv square over r. Here is r. Okay. So if you want to solve this equation, you can see that we have T1 is equal to 1/2 of mv square over r sin theta plus mg over cos theta, and you also have T2 is equal to T2 is equal to the 1/2 or half of mv square over r what sine theta plus mg over cos theta. Okay. You can see that oh sorry, these have to be minus. Okay, you can see that T1 will always positive, right? Cannot have T1 to be negative value, so cannot have any problem with T1, but we can see that T2 can be both. You can see that it is possible negative because we have the minus sign here. So if your second term, which means that the mg over cos theta is larger than mv square over r sine theta, we have T2 to be negative. So if T2 is less than 0, the situation is not possible because we cannot have a negative tension. Okay, if you say that the tension is negative, so it means that the direction of the tension T2 negative is point outward like this, which is impossible. Okay, so the point is that you have to show that T2 is less than 0, and we will find that if you substitute all of the parameter, if you substitute all of the parameter, that is, we have, okay, we already have m here, we have v here, and what else? We need r, and you can see that we can calculate r is equal to the 2 square minus 1.5 square, and take the square root, something like this, so we can have r, and the unit is meter. And once we have r, we can have cos theta, which equal to what? Cos theta is equal to 1.5 over 2, while the sine theta is equal to r over 2. Okay, let's calculate r. What is the value of r? R is about 1.32. So this is about 1.32 over 1.5. Okay. So we have all we need. And if you substitute all these numbers into the formula of T2, you will see that in this case, we have that T2 is less than 0, which is impossible. The impossible here is mean that in the problem they say that the string is remain taut, so it has to be positive. Alright, so if you found that T2 is less than 0, so that is impossible.